We're continuing on with lesson 5. It's a long lesson because it's all the word problems. So probably 3 more videos on word problems. But so far I think everything's been pretty easy, right? Hasn't been too bad, the word problems. So for warm up, we are going to solve this nice little one-step inequality. So remember, you need to solve it. And don't forget the rule about dividing by a negative at the end. And then graph it, and then write interval notation. And remember, no decimals. We use all fractions unless they tell us to round. So go ahead and shut off your camera or your video, and then come back and we'll see how you did on this one. To start this one, and it's a one-step problem. Oh, gotta love these. Especially after that big long one over there, right? So the opposite of times -5 is divide by -5. But once again, just like we did here, anytime we divide by a negative, the symbol must flip. So before I do anything, I immediately flip the symbol. So if the number down here is negative, the symbol gets flipped. And then double negatives positive. 5 divided by 5 is 1. So now I have x is less than or equal to. And remember how we don't want negatives in the denominator, but we're allowed to just move it up. -7/5. So now when I go to find that on the number line, if I want to turn it to a decimal to make it easier to find it, that's okay. But your answer cannot be a decimal. Unless, of course, they ask for it, which they rarely do. So that is what you would type into Alex. But if you wanted to go, well, geez, I don't even know where -7/5 is on the number line, you could do -7 divided by 5, and it would tell you it's about -1.4. So what I would do is I just write it over here to the side in pencil, just so I know where it's at. It's a little bit shy of -1.5. So now I have a pretty good graph because Alex is pretty picky about how you graph them. So we have negative, let's do 0, -1, -2. So -1.5 would be about right here. Put a little tick there. So -1.4 has to just be just to the right of it. And like I said, they're pretty picky. If you put it over here right next to -1, they're going to count it wrong. Or you put it over the halfway line, they're going to count it wrong. So you have to know approximately where it's at, just to the right of -1.5. Because you go to -1.1, 1.2, 1.3, 1.4. So I'm going to call this it. It's a bracket, and I can see this is a less than, so it's going to be shaded left. And then when you go to label it on the graph, you label it with the fraction form. So remember, the decimal is only to help you find where it's at. And then we shade everything to the left because it's less than all L's. Looks like an L, red less than, shade left. And then negative infinities here. So for interval notation, we bring the 2 endpoints down in the exact same order as the graph. This one always gets a parenthesis, infinities always. This one will get a bracket because of the equal sign. So there we have it. So you see on the practice test, both of them had division by a negative, flipping the symbol. So don't forget that. That means it's going to be on the test for sure. Okay, so 2 more problems to finish on this, and then we can move on to working on the word problems in the practice test. So we are working on, like I said, the last 3 pages of lesson 5, page 16, 17, and 18, still in that big packet. So we have some more word problems. These, I think, are kind of common sense problems, these next 3, but you do have to show your work. So I'm going to show you the appropriate way to show your work, but they are really kind of common sense problems, but I'll show you how to fit them in formulas and show your steps. So when I see miles, speed, time, I immediately write distance equals rate times time. And that was one from the last page that I said you should know. You need to know it for your next class. So we have a whole chapter on word problems in the next class, and distance equals rate times time are 2 of them. No. There's 2 in the notes, but there's 1 on the test. Yes. So you do have to know it. So I can plug into this formula and find out what they are asking for. So the hint was seeing miles, time, rate, boom, distance equals rate times time. So we know the distance, 476. What was their average rate? So we don't know rate, so we keep that as R. Now time, and this, remember, is time driving. They left at, say, 7 a.m. They got home at 4 p.m. Or excuse me, they arrived at their destination at 4, but they stopped for an hour, so you can't count that hour. So from 7 a.m. to 4 p.m., I like to do it up to noon. So 7 to noon is 5, noon to 4 is 4. So that's a total of 9 hours. And you can count on your fingers too, 8, 9, 10, 11, 12, 1, 2, 3, 4. But I just do it in comparison to noon. So this is 7 to noon is 5 hours, noon to 4 is 4 hours. So they were on the road 9 hours, but 1 hour they stopped to rest. So I can only use 8 hours because this is all about driving time. So then I put my 8 in. Again, I immediately flip it over, put it in the right order so I have a clear understanding of what my next step is. Variables always on the left, numbers before the variables. So 8R equals 476. Divide both by 8. And what do we get? 476 divided by 8 gives us 59.5. And does it say to round? No. So do not round. So 59.5. And remember what I said, 1 point of every word problem is labeling the answer. So R is rate. So when you're driving a car, your rate is miles per hour. And we can see that. Miles per hour. So then I just put M, P, H, or I can write it out. So this shows the teacher you understand what you found. That's why I count it as a point or sometimes 2 points on every word problem. Otherwise, you're doing mindless math. You're plugging in numbers and you have no idea what you found. This grounds you, makes you stop a second and go, okay, R stands for rate. Rate of a car is miles per hour. And let me just make sure I type that in correctly. 476 divided by 8. Okay, because it's kind of weird that it came out a decimal, but. Okay, so that was a nice easy one, right? The next one's nice and easy too, so I'm going to let you guys try that one. I will tell you one thing in case anybody doesn't know. A pentagon is a 5-sided figure. How I remember it, pent house. A house has 5 sides. Think about what a house looks like. You know, like our stick figure houses. So that's how I remember pentagon. I always have all these little tricks, but I make them tricks that I remember for life. penthouse, pentagon. I know a pentagon is 5 sides. So that should be the first thing you do. Go ahead and turn off your video and see how you do. So you're going to write an equation, solve the equation, and then you're going to find the length of all 5 sides. And then come back and we'll check your answers. Okay, so the perimeter of a pentagon, so they're already telling us the perimeter is 130 centimeters. And anytime I come across important information, I write it down because sometimes it gets lost. And when you're working computer tests, you can't underline it. So in lieu of underlining it, write it down. Okay, the sides are X centimeters, 0.5 X centimeters, 2X centimeters, and 2 sides are 1.5X. So remember how I said the other day, every time you have a geometry problem, you draw that picture. Otherwise, you got to write 5 variable statements. Side 1 equals X. Side 2 equals. Draw the picture, boom. Your variable statement's done. Okay, so geometry always requires a picture. We do that in lieu instead of writing variable statements. Well, this is the reason I don't have you memorize a formula. That 2L plus 2W that maybe another teacher told you to memorize doesn't work on a pentagon. So we learn what the meaning of perimeter is, the distance around the outside. We have the perimeter of the building surrounded. That's all around the outside. So you take the first side plus, and if you want to put a 1 in front to remind you, plus the second side, plus the third side, plus the fourth side, plus the fifth side, equals the perimeter. So just understanding what perimeter means, all the sides added together. It's all around the outside. And probably easiest to do this in your calculator, especially if you're doing a test. And remember, we're just doing the numbers in front, not the x's. So 1 plus 0.5 plus 2 plus 1.5 plus 1.5. So I'm going to guess it first before I look. 3, 4, 5, 6.5. Yes! I always like to do that. I'm a math nerd. I like to play games. So 6.5x equals 70. And then the next step, and opposite of times, is divide. Divide both sides by 6.5. And why do I feel like I have this wrong? Duh. You guys are supposed to be screaming at me through the thing. I use the last perimeter instead of this one, even though I have it written really big here. But I was like, do you ever get that tingly feeling like, ooh, I'm doing something wrong? And I just got that feeling because this just doesn't look right at all. So there's where I made my mistake. It's kind of weird. It's like one of those spidey things, you know, I just like wasn't feeling it. So to find my x value, x equals 130 divided by 6.5. 20. And we know that the label's centimeters. And remember what we've learned throughout these word problem videos. This is the value of every x in the problem. So we could do first side is x. So it's going to be 20 centimeters. because it says find all 5 sides. The second one is, let's do this, x equals. The second is 0.5 times 20, which would be 10 centimeters. How do I do that in my head? That means half of 20. And the third side is 2 times 20, which is 40 centimeters. And the fourth and fifth side, fourth and fifth, is 1.5 times 20. That means 20 and half of 20, so that would be 30 centimeters. So that's what 1.5 means, a full 1 and a half. A full 1 is 20 and half of 20 is 10. 20 plus 10 is 30. You can do it on your calculator, but like I said, I just like to do stuff and try and do it in my head. And so that's what it asks for. Find the length of each of the sides. So there you have it. And if I was taking a test and this is a problem, I'd rip that calculator right out and I'd add and make sure we get 130. So we have 20 plus 10 plus 40. Can't even read my own writing. Plus 30 for the fourth side, plus 30 for the fifth side. Cross our fingers. Ding, 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 ding. 130 centimeters. So we know we did it right. So there's so many times you can just pause. How long did that take? 30 seconds? Check your work before you move on to the next question. Doesn't take much time. Okay. I'm sorry about that. I had 70 in my head. Wasn't this one down here 70, I think? I think the last one we did, yes. So for some reason, I just remembered that number from the last video. Who knows why? Okay, this one is a good one to do together. It's a little quirky, but not bad. I actually have this problem. The class before yours is called 081, and I got this problem off of it because they have this big unit on area, volume, perimeter, and this is one of the problems I give them. So a lawn is in the shape of a rectangle. Okay, so the minute you see hear the word geometry, draw the picture. With a length of 100 feet. And I'm just going to use that for feet right now just to make it easy. Width of 45 feet. And remember, rectangle means opposite sides are equal. How many bags of fertilizer must be must be purchased to cover the lawn if each bag covers 2,000 square feet? So I train my 081 students, the minute they see square feet, that means area. So they're trained. When it's just feet or just centimeters, that's perimeter. When it's centimeters squared, feet squared, yards squared, that means area. And when it's cubed, that means volume. So the key to this entire problem are those two words right there. Square feet means find the area. And that's how you buy a house, by the square footage. It's the area of all the rooms in the house added together. That's how you buy tile. That's how you buy carpet, by the square footage or square yard. Now, if we're doing sand, sand is cubic feet, so it would be volume. But we don't get into, I don't think we get into too much volume in this class, but that's the hint. And this comes from the class before ours. Square feet, square inches, square miles means area. So I immediately go, oh, this is one of the formulas Miss Norris said we had to memorize. Area equals length times width. So the minute I read those two words, I write this. And then I fill in. The length of the lawn is 100. The width of the lawn is 45. So that area would be 4,500 square feet. That's not what the problem's asking for. They want to know how many whole bags do I need? Well, 2,000 isn't enough. So add another 2,000. Well, 4,000 isn't enough either. It's close, but I can't cover the whole yard with 2 bags. So I have to order a 3rd bag and have some left over. So you can't have less than you need. You have to have more in order to cover the yard. And you can't have a partial number of bags because it says whole bags. Mathematically, you could do it like this. 4,500 divided by 2,000 to see how many bags are in it. You could cut off a couple zeros to make it easier to type in the calculator. 45 divided by 20. And you can't buy 2 bags. You can't buy 2.25 bags, so that tells you to buy 3 bags. Because you can only buy whole bags. So like when you're doing carpeting, when you're buying fertilizer, those kinds of things, you just got to round up because you have to have more than you need. You can't have less. So you could do the 3 bags this way, looking at it visually, or you can do it this way using the math. I mean, they're both using math, but in different ways. So how many bags go into the yard? 2.25, but I can't buy 2.25, so that means I need 3 bags. Not bad, right? My students do that in 081, and guess what? They do it without a calculator. They don't get to use calculators in their class. So they would do it like I did. I mean, you don't need a calculator for this. Multiplying by 100, add 2 zeros, and then you start going, is 1 bag enough? Nope. 2 bags is 4,000. Is that enough? Nope. So they have to get the 3rd bag that will cover 6,000, but they can only buy whole bags. So yeah, they do all their work without a calculator. Well, there's one chapter they let you use a calculator on, the when they're doing volume and stuff, because then the numbers get pretty big. Okay, so this next section, not students' favorite section. But it should be, because you guys are really good at solving equations now. We've been working on it for the last 5 lessons. And solving a formula is just like solving an equation, but sometimes there's multiple letters. Doesn't matter. So when I see, and I'll do this first one, I'll let you guys try the second one. So when I see I'm solving for B, I immediately flip this equation over because I want the letter I'm solving for on the left, and that's how we're used to seeing it. And I think sometimes students just don't take the time to do these little things, and they're the difference between getting it right and wrong. So you say to yourself, I need to get B alone. Oh, well, we learned in this chapter, anytime there's a fraction, we need to multiply both sides to get rid of the fraction. So this is one term, no addition and subtraction, so I multiply it by 3, and I multiply this by 3. Exact same steps you would do if there were numbers. Get rid of the fractions. And so I'm left with 1BH, which is just B times H, equals 3V. So look what an easy problem it is now. All you had to do was remember to get rid of fractions first, and now it's a one-step problem. How do I get B alone? Do the opposite. The opposite of times H, divide by H. Done! B is now alone. So my answer will be B equals 3V guess my green's running out of juice, huh? Over H. So that's what solving a formula for a designated variable is. You take the given formula, whatever letter they want you to solve for, you put that side on the left, and then you undo or do the opposite. What's the opposite of divide by 3? Times 3. What's the opposite of times H? Divide by H. Do the opposite to get that letter alone. Okay, B's yours. So go ahead and turn off the video, and you are solving that formula for R. And you are not allowed to put numbers into formulas, so do not put 3.14 in for pi. That is wrong. You can only put 3.14 in if they ask you to, because that's an approximation for pi. So don't put any numbers in, just solve the formula for R, and then come back and we'll check it. I guess I gave you too easy a one, huh? Well, I'll have you do D after we do C, and that won't be quite as easy, although it is pretty easy, as long as you follow what we did here. So this is a one-step problem. So the first time I see that it's solved for R, I flip the equation around, and then I remind myself what this means. 2 pi times R. Well, to get R alone, we do the opposite. And I'll tell you, students make these so much harder than they have to be. They are no harder than solving with numbers, and usually easier. You just have to remember you're undoing. You're doing the opposite. So 2 pi divided by 2 pi, gone. And so my R is now alone, so my answer is going to be C over 2 pi. Once you get the letter alone that they're asking you to solve for, you're done. So R equals circumference divided by 2 pi. Okay, let's do one more together, and then I'm going to have you do this one, and I'm going to give you a hint. When you do this one, you want to get rid of the fraction, like we did up here. And remember, when you multiply both sides by 2, do not go in the parentheses. We learned that way back in, I think it was lesson 3, when we were learning how to get rid of fractions. You only multiply what's outside by 2. So I'll give you that little hint. I hate to see students fail, so I always like to give some hints. Okay, this one we're solving for L. So again, I'm going to do the little cursive L just so I don't get it mixed up and think it's 21. And I'm also going to flip my equation over because I'm trying to get L alone on the left-hand side. So when students struggle with this one, I just say, put your finger right there. Don't touch what's under your finger. You want everything else to the other side. So what are you going to do? Well, the opposite of add 2w is subtract 2w. So minus 2w minus 2w. So 2L equals P minus 2w. And look at that. I almost have L alone. One step away. So there's 2 different ways you can do the next step. And I don't think any teachers or computers would care which way. So one way you can do is divide by 2, divide by 2, divide by 2. And so you get L equals P over 2 minus W. Oh, Chihuahua, Kim, 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 Kim. Minus W. So that's one way. And you know, I have to get out my liquid paper because that's driving me crazy that I got something crossed out there. So let me deal with that. There we go. Okay, next, other way you could do it. at that step. So you're at 2L equals P minus 2W. And you could also just choose to do one big one on the right and one big one on the left. I myself kind of like that one better, unless I'm asked to do otherwise, less work. I didn't have to know to simplify that. And I can't simplify here because it's subtraction. So on this one, you have to remember to simplify. And if you don't, it's wrong. On this one, there's no simplifying because we can't simplify during subtraction. So I prefer the second, but I just want you to know either way, it's counted correct. So P minus 2W over 2, and no, the 2's cannot cancel. There's a subtraction there. You can't take 2 away from one term and not the other. So you just stop. So this could be your answer. Alex and teachers will count this right, or this could be your answer. Either one. Okay, for the last problem on this video, you get to practice, and this is the one I put on the test. So this is a great one to practice on. So remember what I said. First thing you do is get rid of the fraction. Then maybe flip the equation over if you need to. Maybe distribute if you need to, but your goal is to have B sub 2 alone by the end. Okay, go ahead and work on that one and come back when you're ready to check it. Okay, so this was the thing I was warning you about on before you did this one, is when you're multiplying by 2, everybody agree the LCD's 2, that's the only denominator in the whole problem, right? You only have to do it once on the right. Why? Because 1/2 and h go together, and this is inside parentheses, and we never go inside parentheses with the LCD. So that's kind of a risky step there. A lot of students forget that rule. Every term has to be multiplied by 2, but legally there's only 2 terms in this problem. One on the left, one on the right, because all of that is in parentheses. So it's like a big multiplication problem. 1/2 h times that quantity. So 1, 2 on the left, 1, 2 on the right. The one on the right immediately cancels. I'm going to flip this over as I write it. So it's h, and I can drop the 1 because 1h and h are the same thing, times b1 plus b2. And they're really read B sub 1, B sub 2. But I remember when my professors used to say that, I'm like, what is sub? So I always just say B1, B2. Well, sometimes I say sub. Okay, so there's our new problem. A lot easier to look at. Everything's on the right side. No fractions. So I can't solve for B2 when it's in there. Only when it's outside. So I have a couple options. I could divide by h and then the parentheses drop, but I would say the good majority of students on this one on the test distribute, because that's what we're used to doing when we have parentheses. So I'm just doing it the typical way of students, but I'm just telling you this isn't the only way. If you did it the other way, your final answer would be 2a over h minus b sub 1. So if you have that as your answer, it's correct. But my way is not going to show that answer. It's going to be equivalent to that answer, but it's not going to look quite like it. So distribute, hb sub 1 plus hb sub 2 equals 2a. And then I put my finger over the term that I'm solving for so I don't move it. Everything else goes to the other side. I cannot move that. That needs to stay put. So that's why I always put my finger over it so I don't move it. So what's the opposite of add HB sub 1? Subtract HB sub 1. And so that leaves me with H times B sub 2 equals 2A minus HB sub 1. This problem sounds so much scarier than it is with all the subs. And then your last step, get B sub 2 alone. And that's why I put the times sign in to remind me, oh, that's times. To get B sub 2 alone, all I have to do is divide both sides by H. Done. So there's my answer. B sub 2 equals 2A minus HB sub 1 all over H. And that's the one I put on the test. I like that problem. Has a little bit of clearing fractions, some distributive. Yeah, it's a good one. My favorite of the 3 that we had. I feel like this one might be on there too, or maybe half of you will have this one, half of you have that one. Alex sometimes will send out different problems to different students. So I would maybe highlight both of these. Very similar, except for the second one has the fraction. I didn't have enough room to write it, but if I can sneak it up here if that's bugging you that I didn't rewrite it. So it's 2A minus HB sub 1 all over H. And no, the H's don't cancel. You would have to take H out of both to cancel. So you just leave it just like that. And you always know you're done when the letter they ask you to solve for is all by itself. So basically, it's just a matter of remembering to do the opposite. Okay, that's it for this video. 2 more pages left in lesson 5. So I'll see you on the next video.